After watching this video lecture, students will be able to describe the steps to prepare solutions, as well as prepare dilute solutions and explain the subsequent calculations connected. So the preparation procedures that we're going to be using to make solutions are going to vary depending on if we are preparing a molal or a molarity solution. So we're going to start by talking about the molarity solution and its steps, and then we'll talk about the molal solution. So step one is going to be to obtain the equipment that you need. Okay, so if you're making a 500 milliliter solution, you're going to need a 500 milliliter volumetric flask. Volumetric flasks are already calibrated to whatever specific volume value is indicated on the flask. Okay, so there's no need to measure your liquid portion's volume. All you need to do is follow the marking on the flask. Okay, so what you'll do is take your molarity as well as the volume you're trying to make, and you will subsequently do the work to calculate how many grams of the solute you will need. We've already done that. Okay, so you're going to first weigh your 45.0 grams of NaCl and add it to the 500 ml volumetric flask. Okay, then what you'll do, step two, is you're going to add some deionized water and swirl. Okay, now you want to add a little bit of deionized water and work on getting the solid as dissolved as you can. If you add all the way up to the calibration line with that deionized water, it'll make it very, very difficult for you to agitate the solution in the container, and it'll take a really long time for the solid to dissolve. So basically, you'll add some deionized water, you'll swirl, you'll add a little bit more, you'll swirl. Okay, and then eventually what you'll do is you'll add the remaining deionized water up to the calibration line on the flask. And then at that point, you will have created the solution with the correct concentration that you need. Now, some of you may be asking, why are we using deionized water? Well, anytime you're preparing a stock solution in laboratory, you want to make sure you know what's actually in the container. You don't want any reactions happening or anything of that sort. So deionized water is water that has been vaporized and then the vapor condensed down. And basically what that does is it removes any ions that were picked up as it ran naturally through the ground. Okay, so basically deionized water is what you're going to be utilizing for any of your preparations. Okay, so now let's go ahead and let's look at the preparation of a molal solution. So in this context, guys, all we really care about is the quantity of our solute, its mass, as well as the relative mass of our solvent. Okay, so what we're going to go ahead and do, there's actually two ways you can go about doing this. Okay, first of all, you're going to weigh your solute, okay, and add it to your beaker. Okay, now make sure that your beaker is of adequate size to hold the approximate volume of the solution that you're going to make. Okay, now we're going to add 0.5 kilograms of water. Okay, we have multiple options here. That's a lot of mass. Most scales won't be able to manage that, but if yours can, you could go ahead and put your beaker with your solute on the scale and then just add 0.5 kilograms. The other option is for you to use the density of your solute, or sorry, your solvent, to figure out how much of the liquid you need to add. Okay, so there's multiple options there, so it's kind of up to you what you want to use. But so step two, either weigh or calculate with density the volume of solvent, okay, and add it to the beaker. Okay, then swirl. Okay, now Your solvent is, in this case, water, okay? And in the case of water, I will never give you the density of water. It's assumed that you know, but if it's a different substance, then I will tell you that specifically. Okay, so this is just simple solution prep. Make sure that you're comfortable with the steps. Anytime you're saying you're adding water, please make sure that you're being specific that it's deionized water. Dilutions. Okay, so guys, dilutions are basically solutions that are prepared by adding additional water to a more concentrated mixture. Okay, and so you guys may have done this when you've made like maybe a Mio drink. You know, you have the little dropper concentrates with flavorings for your water. So basically, you know, you add a little bit of that Mio to, you know, your glass full of water, and you subsequently have a drink that, you know, tastes pretty good. So in that sense, basically, dilution is when you're adding water to make something have a lower overall concentration. Okay, so in the case of dilutions, the number of moles of solute are going to remain the same, but the volume of the solution is going to change. Okay, and that's why we can use this equation here. Remember that molarity times volume in liters is going to be equal to moles. Okay, so moles of the solution, moles in the solution that you're starting with versus the moles in the solution that you will end up with will be the same, but the concentrations will differ because of the volume. So let's go ahead and let's do some practice problems. Okay, so they ask you here what volume of 15.8 molar nitric acid is required to make 250 mils of a 6.0 molar solution. Okay, so basically they want to know the volume of this concentration of HNO3 that's going to allow me to make 250 milliliters of a 6.0 molar solution. So this is an M1V1 equals M2V2 problem. What I'll do with my M1V1 equals M2V2 is I'm going to manipulate my equation before I plug anything in. So V1 equals M2V2 over M1. Okay, and then what I'll do is I'll make sure my units match, right? We got molarity, molarity. This is milliliters, but I'm going to change that into liters so that we have everything in the correct kind of units. Okay, we're then going to plug everything in. So V1 equals M2, which is 6.0 molar, times my volume, which is 0.25 liters, all over 15.8 molar. Okay, so we're going to plug that into our calculator. That's going to give me a 0.0949. Okay, units that cancel are molarity, molarity. Liters are left over. Okay, and then significant figures wise, we got 2, so 0.095 liters, or 95 milliliters is what I would need of the 15.8 molar HNO3. Okay, now what you guys need to notice here or recognize here is that I am taking a more concentrated solution. I'm taking 95 mils of the more concentrated solution, and I'm diluting it up to 250 milliliters so that I have a 6 molar solution. So in this case, when we're preparing this solution, we're still going to use a volumetric flask. We're still going to have to measure everything. But in the case of this particular problem, we're going to have to measure out our solute with a slightly different instrument, right? We're not going to do it by mass, we do it by volume. So that's when a volumetric flask or a pipette would come into play. Okay, let's go ahead and let's look at this next problem. It says, what is the new concentration of a solution when 10 milliliters of 2.2 molar sodium chloride is diluted to 100 milliliters with deionized water? So once again, this is an M1V1 problem. Okay, in this case, they want us to calculate the M2. Okay, so we got M1V1 equals M2V2. We're going to manipulate and solve for M2. Okay, so M2 equals M1V1 over V2. Okay, we're then going to put all of our units into liters. Okay, so we're going to move our decimals here and here. Okay, and then we're going to plug in our values. So M2 is going to be equal to M1, which is 2.2 molar, times our V1 is going to be 0.0100 liters divided by 0.1000 liters. Okay, we're going to plug that into our calculators, and that's going to give us 0.22 molar as our new dilute solutions concentration. So I want to go ahead and talk about acid solution preparation, and I want to talk about it in the context of the first question on the previous slide. Okay, so basically on the last slide, we calculated that we needed 95 milliliters of our 15.8 molar HNO3 in order to create this solution here. Okay, and of course we need a 250 milliliter volumetric flask. We would measure out our 95 milliliters of the concentrated HNO3. So when we do this, or when we've shown other examples, we normally put the solute in first and then added water. But in the case of acids, when acids get dissolved in water, a lot of times they will release heat. And that heat obviously is going to be transferred into whatever gets put into the solution. So if you add the acid and then follow it up with the water, what will end up happening is that heat transfer will cause the the liquid water to vaporize, and you'll subsequently end up with splattering. And splattering and concentrated acids are no good situation. So what you would need to make sure that you do before you add your acid is that you put a little bit of water in the container. Okay, so you would add some deionized water followed by your acid, and then go through the normal dilution procedures. Okay, so we follow the little memory device here called do as you oughta, add acid to water, or I always remembered it by A&W root beer, acid to water. That's how I always remembered. But whatever you need to do, always remember that you always add acid to the water whenever you're doing these preparations.